All right. So we were talking about matrix operations, and the last thing we did is multiplying a matrix by another matrix. But now here quickly, I will show you, maybe you might know this one more time, how do we do this in Excel? And to do this, let me just share my screen. Share screen, okay. Makara, can you see the screen?
Yes, sir. I
Do
see.
you see the Excel?
Yes, sir. Yes,
Very
Excel.
good. Okay. Anyway, guys, also we can actually, because multiplying or adding or subtracting two matrices, as you see, they just follow a fixed rules. That means that it's possible to write a program for them. That's why actually in a lot of softwares, actually they have, these are defined. Addition of matrices and subtraction of matrices, multiplying a matrix by a scalar, or multiplying two matrices, together. These are all defined. Number one is, let's just start with addition. Let's say we are talking about, here we have test 1 and the test 2 and test 3 of the first term. Okay, and let me just, here this one is semester 1, and here we have semester 2, right? And also here we have test 1, test 2, and test 3. Okay. Okay, here we have 3 students. Let's say we have A, B, C, and D. Let's say 4 students. And also center this. Okay, these are the students. And let's say that's their scores. Let's semester 1, let's say calculus 1, semester their calculus 2. Okay, this A got, let's say 70 and 90 and 40, 56. And this guy maybe 35, 65, and after that 90. This guy maybe 30, 40, and 50. And this guy 20, 76, 89. And test 2, something like that, let's say 87, 98, and 67. And this guy is 67, 98, 88. And we have 29, 50, 65, 78, and 22, 56, 78. Anyway, so these are their scores, and this one is, let's say, semester 2. Okay, you can see the difference. This one is semester 1. Let's say there's something like this, right? And let's say this is test 1 in the first semester, test 2 in the second semester, test 2 and 3. Okay, if you want to get the average of the year test, for example, let's say test 1 average, test 2 average, right? How do we do this? If you want to get the test 1 and test 2 average, I can just write here, let's say average here, average score. Okay, you just write here, average. Okay, and here we have test 1 and test 2 and test 3 of 2 semesters. How do you get this? To get the average, this, for example, let's say student A, right? I should add 70 plus 87, right? And I should divide this by 2. That gives us the average of test 1. And this 90 plus 98, I should divide this by 2, right? I can do this by one. But how about if we just consider this as a matrix? Because as you see here, we have 4 students. How about if we have 200 or 400 or 500 students? Doing one by one is not a practical method. But when you use matrices, you will see that it's very, very simple. Here, to do this one, that means that if this one is matrix A, right, this one is matrix B, so that means that here, I should just, this one is matrix A, and this one is matrix B. what we have to do here is I need to just add A plus B, right? And I should multiply this by 1 over 2. That means that it is adding this 70 to 87, the first component to the first component, and dividing by 2. That gives us the average result of test 1 in the first semester and test 1 in the second semester. So to do this one, what we have to do here is I should just add these two matrices and multiply by 2. So what can I do here? So here, I should first choose our destination cell and write equal here, okay? Then here we have 0.5 and multiply. And here we have matrix A, that is matrix A, okay? I can just write here brackets and the plus matrix B. And also I have to choose this matrix B and close the brackets. But if you just press enter here, it will add only one component. And that's why if you remember to do this one, we need to press Control Shift Enter together. So if I just press Control Shift Enter, we will get the average of these scores. As you here, 20 plus 22 over 2, that is 21. And 89 plus 78 divided by 2, it is 3.5. 76 plus 56 divided by 2, it is 56. Okay, that is one, how to say, practical way. I mean, good application of matrices. Now the second one is, how about if I want to, for example, somehow I made a mistake, let's say in test 3 of the students here. Okay. Okay, for example, let's say again, these students, let me just write here, okay, and they have, for example, let's say math course, and the total average is, let's say 89, this one is 87, this one is 67, and this one is, let's say 65. Okay, so actually, maybe to some reason, I want to increase the year score. By how much? Let's say by 10%, right? 10% means increasing something by 10%. As you know, actually, if you want to increase something by 10%, let's say it means that it's X. I need to add 10% of X to this number, which is equal to 10%, 100%, which is equal to 1.1X. So that means that to do this operation, I need to multiply each number by 10. How can I do that? To do this one, for example, let's say I want to write the result here. So choose the destination cell and write equal 1 times 1 and multiply by this matrix. And if I just click here, not enter, Control Shift Enter, that means that all results are increased by 10%. Okay, that is the use of these matrices. Now another one is, let's say I want to multiply this matrix by this matrix. How can we do that? To do this one, I need to choose destination cell. This one is 3 by 3 matrix, right? This is 3 by 3, and this also 3 by 3. And I want to write the results here. So first we have to select the destination cell, because we know that if I multiply this matrix by this, and also the product matrix will be 3 by 3 matrix. So I choose this and write equal. So choose this matrix, that one is this, and times, and here we have this matrix, right? I can do like this. Or another way is, we should do like this, MMULT, that is matrix multiplication. Open bracket, as you see here is asking array 1, so that is array 1, and comma, we need to put here array 2, and close the bracket. Now Control Shift Enter. So in this way, we can multiply two matrices. Okay, what's happened here? B3, okay, and B, D9, D6, okay, D6, 3 by 4, and 3 by 4, okay. So as you see here, it's wrong because this matrix is 3 by 4, and this one is 3 by 4. We cannot multiply 3 by 4 matrix by 3 by 4 matrix, right? Because this one is 3 by 4, and this one is 3 by 4. As see here, these numbers, number of columns of the first matrix is not equal to the number of rows of the second matrix. So we cannot do this multiplication. That's why here we have wrong message. And how about, for example, if I just multiply, let me just enter something different. Let's say here we have 1, 2, 3, 4, 2, 3, 4, 5. And here we have 4, 5, 6, 7. Let's say 6, 7. This one is 3 by 4. And here we have, let's say 1, 2, 3, 4. That is 4 by 1 matrix. This one is 3 by 4. This one is 4 by 1. I can multiply these two matrices, right? So this one is 3 by 4, 4 by 1. The resulting matrix will be 3 by 1. It will be here. We have 3 by 1 matrix. So equal, and here we have MMULT, matrix multiplication, and array 1, and multiply by array 2 here. And close a bracket, Control, Shift, Enter. We have the result here. Anyway, guys, this is how we multiply matrices using Excel. And see here, if you actually don't have some knowledge about multiplication of two matrices, if you do not show the destination cells, this computer cannot multiply the matrices. And you can practice and learn more about this as we actually advance to other topics. And also I will show you how to find it is inverse and some other stuff. For now, that much is enough. Okay. All right, let's get back to our class. Okay, this is how we multiply two matrices in Excel. That's when choose the first matrix M1, the second one M2, MMULT, that is matrix multiplication, and select the destination cells, press F2 and Control Shift Enter, and you get the answer. But press F2, it depends on what kind of laptop you're using. One example for the use of matrix. Okay, that is the application of this product in business. A bakery produces 4 different types of breads, namely enriched white breads, that's E, whole meal breads, that is W, multi-grain breads, that is M, and raisin bread, that is R. Delivery is made to 3 distribution outlets. Outlet A receives 80 loaves of E, 70 of W, 90 of M, and 25 of R. And outlet B receives 90 loaves of E, 20 of W, and 15 of R. Outlet C receives 70 loaves of E, and 35 of M, and 20 of R. The cost of 1 loaf of E, W, M, and R is 0.70, 1.60, 2.10, and 2.20 respectively. Okay, this is a problem. You can just imagine that you have a kind of bakery and you are running a small bakery business. Maybe every morning, as you see in Phnom Penh, actually, some companies, they distribute their products, right, to some shopping centers or local markets or supermarkets. For example, around TK, we have like a supermarket, and Bayonne and Thai, and also Aeon Max Value. For example, let's say like 3 or 4 outlets. So every morning, imagine that these actually supermarkets are receiving their products from the same bakery, what is it? Outlet, whatever it is, bakery, just bakery, let's say bakery company. So here, the question is one by one, calculate one by one. We can actually answer this question. But here the problem is, can we just write such a formula, right, with a single calculation, but just click an enter button, we can evaluate everything at once. Okay, that's the problem. But here, luckily, actually, we can represent everything in matrices. Let's say outlet A, B, C. I can just write here outlet A, and here we have outlet B and outlet C. And we are talking about 4 different products, that is E, W, M, R. Let me just write here, we have E, W, M, and the R, right? For example, A receives from E how many? 80. And from W, it is 70. M, that is 90. Okay, let me Maybe use different color here. So here we have 80 and 70 and 90 and 25. How about outlet B? It receives 90 loads of E, that is 90, right? 20 of W, that is 20, and 15 of R. So it doesn't receive any of M, so that's 0, and 15 of R. Outlet C receives 70 loads of E, that is 70, 35 of M, so W is 0, this one is 35, and 20 of R. So here we have 20 of R, right? And that is our first matrix. If I just actually put here the rectangular brackets, as here, it's just a matrix. Now also the unit prices are given here, the unit price of E, W, N, and R, right? So I can just write it as unit price as Q. Let's say I can just write it like this so that we can multiply this. The first one it is 0.70, the second one is 1.60, third one is 2.10, and 2.20. So as you see here, when we multiply these two matrices, we multiply 80 by 70, that is the unit price of E, 70 by 1.60, 90 by 2.10, 25 by this. The second row, that means we are talking about outlet B, 90 by 0.70, 20 by 1.60, 0 by this, and 15 by this, right? And also for outlet C, you can see this. So that's actually, it says that form two matrices here, Q and C. So that is our matrix Q. And this one is matrix, what is it? C, quantity and cost. And evaluate QC. After writing this, now we know how to multiply this. Even using Excel, you can multiply this. 80 times 0.70 plus 70 times 1.60 plus 90 times 2.10 plus 25 times 2.20, that's equal to 412, what is it, dollars. The second outlet, outlet B, 90 times 1.60 plus 20 times 90 times 0.70, 20 times 1.60, 0 times 15, right? And also multiply these two matrices, we will get this. And explain clearly what the elements in QC represents. And what are these elements representing here? The first element, the second one, third one. It means that that is the total revenue, right, that you collect from, this one is outlet A. This one is from outlet B. This one is outlet C. Because at the end of the day, if you just suppose that all products are sold out, right, at the end of the day, you should go and visit these shops. Again, you need to collect the revenue. So actually, you have to collect this amount from outlet A, this amount from outlet B, and this amount from outlet C. Okay, that's one simple application of matrices and how we are using multiplication in business. When you just write this in systematic way, as you see here, our actual work gets much, much easier. All right, let's continue. Now, another example that is, what is this? Using the matrix multiplication and solving the system. And from now on, we actually frequently use this. For example, here, if you're given the system, and before I write this, let me just write a little bit simpler system. Like, for example, if we have here 2x plus 3y is equal to 7. And this one is, let's say, 5x plus 9y is equal to 11, right? That is a system of linear equations, okay? And if you just close this x, x, and y, y, what do you see here? Here we have 2, 3, 5, 9, and 7, 11. Even if you just delete this equal sign, we will see a kind of matrix, all right? As you see here in different form, I can write this equation in this way. And here we have the coefficients of these variables. Here we have 2, here we have 3, here we have 5, here we have 9. And here we have x and y. On the right-hand side, here we have 7 and 11. If you check this out, here, if you multiply these two matrices, what we have here, 2 times x plus 3 times y. since when two matrices are equal, if they have the same size and their corresponding entries are equal. So here that means that 2x plus 3y should be equal to 7, which is the first row of this equation. Now, if you multiply this xy by the second row, 5 times x plus 9 times y, that is 5x plus 9y. That's equal to 11. That gives us the second row. Now, if I just label this matrix as actually our coefficient matrix, so let's say label this by A. And this unknown, let's say just label by X. It's a vector. And on the right-hand side, let's denote this by B. It's also a vector, right? So in very compact form, I can just write it as A. Here we have X is equal to B. Okay, now here I'm just not writing cap from the context. You can see that actually these are vectors. This is a vector, this is a vector. So this A times X equals B. As you see here, a big system, right? Systems of linear equations in a very compact form. I can just write it as A times X equals B. And how about for this system? In similar way, I can just write it here as coefficient matrix, that is 1, 3, negative 2, 1, 3, negative 2. The second one is 3, 5, 6, 3, 5, 6. Third line is 2, 4, 3. And now here we have the variables, that is x, y, z. And on the right-hand side, we have that constant vector, that is 5, 7, 8. Now, once again, if I just label, see here, this one is just a matrix, right? If I label this by capital A, and this one is by, let's say, X bar, that's a vector, and this one is by, let's say, vector B. What we have here? Here we just have A and X is equal to B, right? These are vectors, that's why I'm using bar here. So in very compact form, we can also just write this as this form, A times X equals B. That is another use of matrices, okay? All right. So now let's continue. Now we will actually introduce some concepts so that we will need them to do some calculations in very short form. Very simple theorem here. Let A be an M by N matrix. That means that A has M rows and N columns, right? And E sub I. E sub I, a 1 by M standard unit vector. Okay, and E sub J, that is N by 1 standard unit vector. Then E sub I times A is the ith row of A. And A times E sub J is the J's column of A. Okay, what do we mean here? That means that simply, if we, let me just, before we continue to prove this, if you just think that we are given a matrix, let's say it has 1, 2, 3, 4, 5, 6. These are the entries of the matrix. As you see here, this one is 2 by 3 matrix. Okay, so let's say here we have these unit vectors, E sub 1. In E sub 1, what is it? It is 1 by M standard unit vector. So E1 is a row vector, right? E sub 1 means the first component is, what is it? 1, others are 0, right? And here, as you see here, this M, right? And here we have M. So this matrix is, what is it? This matrix is 2 by 3 matrix. And that one is M by N. Here we have M is 2, N equals 3. So that one is, this EI is 1 by M. T our M is 2. So it is 1 by 2 row vector, right? So here we have 1, 0. And how about E sub 2? That is 0, 1, right? So now what happens if I multiply this A by E sub 1? Let's do this one, E sub 1 I. What do we have here? E sub 1 is 1, 0. And here we have A, that is 1, 4, 2, 5, and 2, 6, 3, 6. right? And we know how to multiply this. This one is 2 by 1, 1 by 2, 1 by 2. This one is 2 by 3. The resulting matrix will be 1 by 3. So here you will have this kind of answer, 1, 2, 3, right? So we know how to multiply this. 1 times 1, 1. 4 times 0, 0. So the first entry is 1. Now I should multiply by the second column, right? 2 times 1, 2. 5 times 0, so that is 2. And 3 times 1, 3. 6 times 0, 6, and 3. And what are these actually? It's exactly the same as the first row of A, right? So that gives us, if you multiply E sub 1 by A, it gives us the first row of A. In a similar way, if you multiply E sub 2 by A, so E sub 2 is, here we have 0, 1, multiplied by 1, 4, 2, 5, and 3, 6, right? And 1, as see here, this one is 1 by 2, 2 by 3. So we will have again 1 by 3 matrix, 1, 2, 3. So here 0 times 1, 0, 1 times 4, it is 4. 0 times 2, 2, 1 times 5, that is 5. 0 times 3, 0, 1 times 6, that's equal to 6. Or is it 4, 5, 6? That is the second row of this matrix. That theorem is talking about this. If you're given 1 by n standard unit vector, and each subject is n by 1 standard unit vector, that means that this one is row vector, right? This one is column vector, right? So if you multiply E sub I by A, it gives us the ith row of A. And if you multiply A by E sub J, it gives us the j's column of A. For with examples, you can just try this second part. That is what it's talking about. Actually, this thing is really important in proving some theorems and denoting some long something. For example, let's say we are given a matrix, right? I just need only one row. How do we get this? That is really important thing in engineering or a lot of maybe even computer science, that to get this one, I should just use this multiplication that gives us only one row of matrix. How about if I need to get only one column of the matrix at the time, just multiplying by E sub j, I can get one column of the matrix. Okay. All right. Okay, let's talk about this, and after that, maybe I'll finish the class. Partition matrices. It will be often convenient to regard a matrix as being composed of a number of smaller sub-matrices. By introducing vertical and horizontal lines into a matrix, we can partition it into blocks. So as see here, we are given a big matrix that is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This one is 5 by 5 matrix, right? So if I just introduce two lines here, and you may wonder, why am I introducing this? Because as see here at the bottom, I have 0 matrix here. All entries are 0, 0, 0. If you multiply this by anything, it will be 0. And that's why I can just take it as all. That means all entries are 0. If you look at this part, that is 1, 0, 0, 0, 1, 1, 0, 0, 0, 0, 0, 1. What is it? That's just identity matrix. And I can just denote this by I, because this one is 0 matrix, right? And that's all. Let's say if you multiply by any matrix, the result is 0 again. And how about this one? This matrix, let's say it is I. If you multiply I by any matrix, just equal to A. And that's why actually we are introducing some horizontal and vertical lines and just writing them as I, and this one is 0. So when we're multiplying by other stuff, we will see that it gives us some kind of convenience, and also we will save time by, what is it, in our multiplication operations. And this one is, it's not a kind of special matrix. That's why I'm just using B. So for this matrix to 1, 1, 3, 4, 0. And for this, here we have 1, 7, 7, 2. I'm just using C. It's not any kind of special matrix, right? So in very, how to say, simple form, I can just label the whole matrix by this. And now it looks like 2 by 2 matrix, right? We know that actually here, these are all matrices. It's not, what is it, a real number. For example, okay, before we continue this, let's talk about matrix column representation of a product. Okay. Guys, here, let me stop, okay? I will continue because if I start, it takes time. And maybe some of you are not here. And also I will just send some reminder about the quiz. So you are having class online, everything is online here. The only way that I can give you a quiz is, of course, either I should use the classroom system, maybe for quiz, so I may do this, I'm not sure. For quiz 1, I will send you questions, as I told you, 5 minutes before the quiz starts, and you have to receive the question. You have to solve the questions on A4 size paper, okay, and scan it well. And after that, send it to me back. But you have to do this during the given time, okay? And more details I will send you by Telegram. That much is enough for today. Thank you very much. See you on Friday.